So here we are trying to evaluate two machine learning models, falls under supervised learning and predicted credit score that has a huge impact in financial sector when it comes to lending money. So the basic idea or the goal of credit scoring is to make a decision whether to approve or reject credit applications. So the role of machine learning in credit scoring is that it can mitigate biasness in credit decisions by training models to avoid factors like color, gender, and age, which leads to reasonable outcomes. So to start with the model, we are using a training data set that was found on Kaggle. We actually found three data sets, but the one we chose is more appropriate considering the data set size as well as how much update the data size is. So data preparation is something really important when it comes to training models. So let me share the code and walk you through. So what we first did is we first loaded the data set and listed the columns and we removed the columns that contains PII information such as customer ID, name, SSN columns likewise. And also we did some cleanup to the data set by replacing special characters with null values. And also we listed all the columns with their data types, and there we notice that there are some columns with incorrect data types. For an example, age. Age is having a data type of object, but it should be a numerical value. So here we uh, listed such columns, and then we replaced or we corrected them and changed their data types to correct ones. And then we listed down, we took account as well as a percentage of missing values and the corrected them using two ways. The one is most frequent strategy and the remove row strategy. So once that is done, we verified that the data doesn't contain any missing values, and then we moved on to outliers. So for this, we used two functions, one to generate box plot, and the other one is to generate a histogram. Uh, and the usage of these diagrams is that if there are any outliers, and if so, we can take actions by removing them, and we can take a visual idea of the data distribution among these columns. So for an example, age, here we can see there are some outliers. So we took some action and we removed those outliers and we generated the uh, diagrams again. And then we noticed that the outliers are now removed and data distribution seems to be practical. And also there are some other columns, for an example, this monthly enhanced salary column. So you can see that the data distribution seems to be practical, so we didn't do any changes, so we didn't want to remove any outliers, so we use the data as it is. So we did all the changes to all the columns that are required, like removing outliers. So if there are no outliers, we use the data set as it is. And then we move on to finding the correlations with target variables using ANOVA p-value, where it is a valuable technique for feature selection and understanding the relationships between numerical features and credit scoring categories. So it is possible to consider the columns to be correlated if the p-value is less than 0.5. So among these columns, you can see almost all the columns are having a value close to 0 and having less than 0.05 value, except for the credit utilization ratio. So on the other hand, chi-square p-value, so that is also used to determine the independence between each categorical feature and the target variable. So features with p-values below certain significant level, for an example 0.05, in this case are considered more relevant. So we can use those columns in our credit scoring model. And then we moved on to data normalization. So we normalize the data using two steps. The first one is using min-max scalar, where it is a common pre-processing step in machine learning to transform numerical features so that they fall within specific range, usually between 0 and 1. So this helps ensure that all features are on a consistent scale and can prevent certain features from dominating the learning process in models sensitive to feature scaling. And the second step, we did the category encoding to convert categorical data into numerical format, so that it can be used as an input to our models. So then we moved on to modeling using two popular uh, uh, algorithms or models. So Vindani will explain further more on this. Over to you, Vindani.
Right, thank you, Dylan. Like Dylan said, now the data set is pretty much prepared for the model creation. So basically, we clean the data, we remove the anomalies, and we even normalized and label encoded now. So let's go into the model creation section actually. So here we are focusing on two models. One is a logistic regression model, and the other one is a random forest classification. So let's focus on the logistic regression model first. So even though logistic regression model is designed to binary classification, but with some techniques like one or the other technique, we can go for a multi-class classification as well. So here we are trying to do multi-class classification for our credit scoring mechanism. Okay, so first actually we divided our data set into two parts. So 70% of the data is going to use for the training, and the remaining 30% for the testing purpose. So here actually we create the logistic regression model, and we ran over around 7,000 iterations to converge, and finally the model were able to bring 65% accuracy for the training and 66% accuracy for the test data, right? And not only that, actually we created the confusion metrics as well to see how these significance of these values. And you can see the heat map here, and if you go down a little bit further, we create the classification report as well, especially to see how precision, recall, and fun scores are calculated. So if I go here, actually I would like to go a quick idea about how accuracy, precision, and recalls are created. So basically, accuracy is based on all true positive and true negative values, and among all the values. So then precision is based on the true positive and false positive. So here the formula, and if you think about the recall, so it's basically true positive and false negatives. So and if F1 score is calculated based on precision and recall values. So the calculation. So I mean, we can discuss about this one a little bit further if required, but to focus on the second model that we have created, let me go there as well first. All right. So here the second model actually random forest classification model that we selected. Here, this model actually were able to produce around 99% accuracy for the training, and it's produced 78% for the test data. And if you think about, if you have a look on the confusion metrics, it's bring this sort of heat map, and the significance for the multiple classifications, which demonstrate how the predicted versus actual significance levels here. And if you go a little down further, here we generate the classification report for this as well. And these are the precisions, recalls, and F1 scores for multiple classifications and levels. So let me go back to the presentation again. Just to conclude our discussion, I would like to compare these two models and explain how these two works. So especially logistic regression is having sort of assumption say that it's considering a linear association among features, but especially in this sort of a data, especially which is related to financial related credit scoring level information might not have a sort of a linear regression. So then the logistic regression might not be the best fit for those calculations or predictions. Here also you can see, especially if you compare to this recall values compared to the random forest classification, especially precision values, those are less than the logistic forest classification levels. So it means in this exercise actually we can say compared to logistic regression, actually the random forest classification is doing best compared to the logistic regression. So in our scenario, actually, for our data set, we can conclude that the random forest classification is doing good. But in your situation, in your data set, the random forest classification might not be the best fit, right? So you have to try out multiple classification models, and to see which one is gonna work for your data, and based on that you have to select your model for your predictions. Not only that, actually, you just need to think about how you can bring new data while on the go, how you can bring new data, and how you can improve your data, your model as well in the future, right? So based on that, actually you can improve the prediction level, and bring best out of your model for the future usage. So having said that, I would like to conclude this discussion, and thank you so much.